Next up is your multiplication by scalar. So the mathematical model talks about something like this. If we have a function mapping set x to r, where x is a subset of r, be a real function and k be a scalar belonging to r. Okay, k is a number, it's a constant which belongs to r. Then the product of k into the function is a function from x to r defined by, what is this, kf of x is equal to k times of f of x. So it's kind of weird, I know, reading through it, but this is what it means basically. 10 times of f of x is nothing but, right, sorry, I think, yeah, that's the right representation. 10 times of f of x. I know it's kind of weird, but right. So this would be something like this actually. Oh yeah, I missed a bracket. That's why it looks weird. Just a second. Not that. Okay. So basically it's asking us to find something like this. Okay guys, that's better. Let me explain this again. All we are trying to do is just see this actually. We're trying to show this 10 of f of x is nothing but 10 times of f of x. That's what it means. That is 10x square. Right? That's it. Nothing else. Okay. So here the domain remains the same. I hope it made sense. But if not, don't worry. We're going to see few set of examples. So here was a concept of multiplying a scalar with a function. Nothing big is happening. Next up is your multiplication between functions. So the the product or multiplication of two real functions. We have function f and g mapping x to r. So the product of f of g of x is same as multiplying f of x into g of x. It's the same concept that we've been seeing from the start. So if we have to solve this, f of g of x, right, f of x is equal to x square minus 1 and g of x is x square plus 1. B two real numbers, real functions, not numbers. Then f of g of x is nothing but f of x into g of x. So as usual, we'll substitute and further simplify. So this is x square minus 1 and this is x square plus 1. And what is the identity that we are looking at? Yes, a square minus b square, which is what? Let me put it this way. It's of the form a minus b into a plus b actually. Is it not? Now look at it. What is a over here? Yes, a is x square. What is b? 1. Right? And this is equal to a square minus b square. Okay. So we basically have the following answer. X square, the whole square is x to the power of 4 minus 1 square, 1. Right? This is your resultant function. Are you getting the difference? Right? So instead of going through this step wherein you are putting 2 and 2 over here to solve f of 2 into g of 2, instead of that we can directly do 2 to the power of 4 minus 1. Okay, so this is the fund. Again, you guys can make use of this, get a similar graph and examine what is happening, what time it takes. Actually here the time difference will be lot. So here too the domain is the intersection between the functions. So you guys can put it in general that all of this we are looking at intersection of the domain. Okay. Then at last we have the quotient of two real functions. So we have the mathematical model. Let f and g be two real functions defined for set x mapping to r, where x is a subset of r. The quotient of x, the quotient of f by g denoted by f of f. Oh, okay, this is f by g actually. is a function defined by f by g of x is equal to f of x divided by g of x, and g of x cannot be equal to 0. And I have an example over there, and this would be your answer. F of x is equal to that expression. We're looking at f of g of x. So let me kind of correct this also. One more mistake. Yeah. Looking at f by g of x. This is f of x minus g of x. So this is nothing but x square minus 1 divided by 2x plus 2. Okay. So this is what is identity over here? Yes, we are looking at a square minus b square. So I can rewrite this as x minus 1 into x plus 1. And in the denominator, what can I do? Yes, I can take 2 common and I have x plus 1. So this further can be simplified as x minus 1, and we have x minus 1 by 2. So you can clearly see that, of course, I have made the question that way that we can simplify. But yeah, pretty much all the questions can be simplified. And that's the whole funda, to be honest. Right, guys, that's it. So basically, this is what we can do with all the functions. Between functions, all this possibility is there, is what we are trying to understand. Right? Yeah, reading through this is kind of weird, I agree. I mean, all of this. But as a whole, I'm sure you guys understood this.